Good day. In year 1, we have learned that in general, a formula expresses a rule in algebraic terms by making use of variables to write instructions for performing a calculation. Some examples of formula that you have encountered thus far include a formula for simple interest. We know that we can calculate simple interest with I equals to P R T over 100, where P represents the principal, R represents the interest rate, and T represents the time. Other formulas that we have encountered includes area of circle, where we know that the formula is pi r squared, where r is actually the radius. Now, notice that all these formula have a single variable, have a rule expressed to it, making this algebra I or this algebra A as the main subject of the formula. So today we're going to learn manipulation of formulas to see how we can, besides making, for example, A as the subject, we can make R the subject of the formula. Let's start off with manipulation of algebraic formula. Say, for example, the formula perimeter. Perimeter of a rectangle is given by P equals to 2 lengths plus 2b. Alright, the subject formula in this case, this formula here, is essentially P. Can we change the subject of this formula? The answer is yes. We can make L the subject of the formula by doing some form of manipulation. What do we have here? At a glance, we know that if we take the perimeter, we minus away 2 breadths, and we divide by 2, we can actually get the 1 length. Same for this, when we want to find out the breadth, alright, we can take the perimeter, minus away the 2 lengths, and then divide by 2, we can actually find the breadth of we find the 1 breadth of a rectangle. Now, for the following formulas A to D, is there a subject of formula? If yes, what is the subject of formula? So for example, this A here, we notice that T is on one side, whereas on the other side, you do not actually have any more T's to be found. In fact, there are other variables like S and A. We can say that this has a subject of formula, and the subject of formula is T. For part B, noticeably, it is not completely a subject of formula, because if we say R is the subject of formula, there are R's over here as well. So this is not. Let's take a look at C, where we say that D equals to square root of B squared minus 4AC. Is there a subject of formula in this case? A subject of formula? Yes. And the subject of formula itself is D, because we notice that this formula here, on the right side of the equation, essentially all the variables, when known, can help us find the value of D. In part D, is there a subject of formula? While R and R are already on the left side of the formula and there are no R's on the right side of the formula, however, more can be done to make sure that it is the R the formula. Therefore, in this case, it is not completely a subject of formula yet. Let me show you using example 7 onwards to see how we can make a specific unknown, make a specific subject, make a specific algebra the subject of formula. Say for example, R equals to 3 plus PS in example 7 here. If we want to make S the subject of formula, we need to be able to actually make S the single variable, and then the other side are all the rest of the variables that we need to find S. Let's tear this apart bit by bit. Since it is 3 plus PS, in order to make it just S, let's first start off by removing whatever that is not related to S as yet. In this case, let's minus 3 on both sides, so that our equation will be left with PS essentially is just as good as R minus 3. We do not want PS, we just want S. So therefore, this is P times S. In order to make it just S alone, I will divide by P on this side so that I can cancel. In balancing equation, when we divide p on one side, we have to divide p on the other side. Therefore, the subject S can be found by replacing, or rather calculating, r minus 3 entire numerator divided by p. So the idea behind making subject is to make sure that every element we tear apart or we move away, we need to end up with that single subject that you want. Show you another example in example 8. Question says make U the subject of formula. When now currently the formula is G equals to K 3T plus 5U. Now, U is over here, alright, and it's within the bracket. So let's remove them. Let's break apart the formula bit by bit. First and foremost, since it is K times 3T plus 5U, and let's remove K first. So to remove K, I actually have to divide by K, divide by K. Alright, so I know now 3T plus 5U essentially is G over K. Now, it is 3T plus 5U, so let's remove the 3T first, alright? So in order to remove the 3T, I will minus 3T on this side, so therefore I'll minus 3T on this side as well. So I know that 5U equals to G over K minus 3T. Now let's tidy the right side of the equation such that it is a single fraction. I know that this will be G minus 3KT over K. Alright, and then in order for U to be the single subject, alright, I will divide by U on both sides, divide by 5 on both sides, and that gives me G minus 3KT over K divided by 5, which is essentially G minus 3KT over K times 1 over 5. Therefore, my final answer, in order to calculate U, is as good as G minus 3KT over 5K. The idea remains the same. Let's first find out what is not immediately related to the subject that you want, and then we remove them accordingly. Now, let's look at example 9, where we have K minus A over 3 equals to 2AK. They want us to make K the subject. This time round, I have K over here, and I have K over here. Notice that K is on the left as well as the right, so let's group our K's together first. Anything related to K, let's put on one side. Anything unrelated to K, let's put on the other side. In order for us to put the K's together, let me change them to something non-fractional first. I know this is K minus A over 3 equals to 2AK. I also know that 2AK essentially is 2AK over 1. So make this non-fractional. I multiply 3 here, multiply 3 here. Alright, so I will know I'll get K minus A equals to 3 times 2AK, which is the same as K minus A is equals to 6AK, because 3 times 2 times A times K. Alright, let's group all our K's together. So I know I will have K minus 6AK equals to A. How did I get this? I make all my K's disappear from the right side. And because I did that to the right, I have to do it to the left. And then I make my A disappear from the right side. So I actually have to add them. So that's where A and A gone. This one gone. Now that I have K and K, in order to make it the subject, let's factorize this first. When I factorize this, please remember this is 1, not 0. 6A equals to A. This is K times the entire 1 minus 6A. In order to make K the subject, therefore, I divide both sides by 1 minus 6A. So that's where I get this as my final answer. Alright. In example 9, a typical exam question in example 9 reads like this. Example 10 reads like this. 1 over x plus 1 over y is equals to 1. Let's make x the subject of formula. In part A, they want us to make x the subject of the formula. So let's look at the question. We have A, 1 over x plus 1 over y equals to 1. To make subject, I know that I can do 1 over x. Anything that's unrelated to x, let me put on the right side of the equation, 1 minus y. I minus 1 over y on both sides. Let me turn this into a single fraction. This gives me y minus 1 over y. Alright? And then this is a single fraction, this is a single fraction. I want to remove the denominators on both sides. So to make it non-fractional, let me multiply both sides by xy. X and x no more, y and y no more. So I know this is essentially y equals to x times y minus 1. So to make x the subject, I just need to divide y minus 1 on both sides, and that gives me y over y minus 1. Part B, not that difficult for you to understand. When y equals to 3, now I tell you what the value of 3 is. Just like if I give you the radius of a circle, you just need to substitute it back to the formula. In this case, it's the same. The formula given to you is x equals to y divided by y minus 1. Therefore, when your x equals to 3 is as good as 3 divided by 3 minus 1. That gives you 3 over 2 equals to 1.5. One more example. Now, given the formula of m squared is made up of b squared plus 3ah. They want you to make b the subject. M squared equals to b squared plus 3ah. Make b the subject, so we know we have m squared minus 3ah is equals to b squared. Now, to find b, we square root m squared minus 3ah. Bear in mind that when we square root, an example I can give you is the number 9. When we square root 9, we know that it is 3. But that's not the only answer. We also have negative 3, because we know that negative 3 times negative 3 also gives us positive 9. So same goes for this. When it is a square root, we must add in our plus minus, because there could be more than one answer. Now in part B, find the values of b when m equals to negative 2, a equals to negative 1, and h equals to 4. B will be made out of plus minus square root negative 2 square minus 3 a h. Be very careful of your sign and the way you press your calculator, because this is negative 2 times negative 2 to give you 4. This is plus 12 to give you plus minus square root 16, and that leaves you with two answers, plus minus 4. We have come to the end of this section of the video. Basically, in today's lesson, we try to make subject. In order to make subject of a particular algebra, a particular unknown, we move all that are unrelated to the other side of the equation. And then with the subject of formula, whatever values I gave you, whatever unknown values I gave you, you can substitute it back to actually find the value of the subject. Just be very careful of how you press your calculator, how you write your formula, and especially when it comes to square roots, fourth root, sixth root, do remember your plus minus sign. At the end of today's assignment, not at the end of today's assignment. For today's assignment, please complete Set 2 textbook, page 158, exercise 6C, questions 7C, 8A, 8C, 9C, 11, and 15. We will catch up and go through these questions. Have a good day.